Hello and welcome. Hello, welcome to the second session in the Hitchhiker's Guide to Artificial Intelligence. This is a session where we look at the AI and the myth of creativity. It's a very provocative session. It's a very action-packed session. I'm delighted to have two of the kind of rock stars of the areas of AI with me today. Lev Manovich, who is the kind of the person in terms of new media art theory, and Daniel Bojon, who I think is the person in terms of AI and architecture, the application of AI to architecture. This is the second of the sessions. All the sessions are being recorded and are being uploaded, and they're taking place at the same time each day for the next 5 days now. So I'm going to move fairly quickly today because there's a lot of material to get through, and I think it's a really hot issue. Creativity is something that we somehow always come back to whenever we're discussing AI. It is the central issue in many ways, and I think it's we can have a very provocative session today. So welcome everyone. I want to start off with kind of a historical background to the question about creativity itself. Ada Lovelace, you might know, was the first is credited as being the first kind of proto programmer. She worked with Charles Babbage on the two machines that he envisaged but didn't fully complete, and was for someone who was very aware of the question of creativity itself. She was the daughter of Lord Byron, the very famous British poet, and at the same time, she was very skeptical about whether AI itself should be creative. The analytic engine was one of the projects she worked on, and she describes in very poetic terms how it is able to weave these algebraic patterns and so on in a very beautiful sort of way. But when it comes to the question of creativity, and here she is on Doctor Who, she makes this very straightforward comment: the analytical machine has no pretensions whatsoever to originate anything. It can do whatever we know how to order it to perform. So basically, it does whatever it is programmed to do. And that certainly is the kind of the standard view in many ways about AI. And it's one that has been repeated by fairly conservative art commentators such as Joanna Selinska, who take the view that really AI, all it does is basically repeat the same. It is simply a form of imitation work. And that, to some extent, also is repeated in the world of architecture. Makoto Watanabe, who remains, I would say, a little bit more open-minded than Selinska, but he makes the comment that machines are better than people at solving complex problems with many intertwined conditions. In that realm, people are no match for machines, but people are the only ones who can create. Who can create an image that does not yet exist. Machines do not have dreams. Now, that's something I want to challenge in today's session. The idea that a machine cannot create an image that does not yet exist. So let me start off then with the question about how maybe AI can be generative. I'm a bit cautious. I don't want to use the word creative, but I want to refer here to a lecture by Blaise Aguirre-Iacos, who is Blaise is the person who set up the artist machine intelligence group at Google. He is a computer scientist and with a deep knowledge of neuroscience and so on. And he gave this TED talk several years ago, describes how as he puts it, computers are learning to be creative. I would question the term creative, but nonetheless, this is the term that he uses. And he explains in this TED talk how AI is able to recognize images. This, of course, is something fairly standard these days. We can see on Instagram how it recognizes images. It can recognize our friends on Facebook and so on. It is extremely sophisticated, but this is something that is relatively new. And what happens, as I mentioned yesterday, we have a neural network here where these are the neurons, these are the synapses, and these are governed by the weights. And basically, the information propagates its way through until eventually it recognizes it as a bird. Now that is remarkable in its own way because it's fairly new. At the same time, the challenge in the world of AI is how you might generate. This is how much you generate images. That's the kind of the holy grail, as it were. So that's the question then that Blaise puts is, but what is the picture of a bird? And what is interesting is that you can actually use this same process in reverse to begin to kind of like to generate an image of a bird. So you start, instead of going from left to right, from image to concept, you start with the concept of the bird and you go from right to left. And using, as he says, the same error minimization procedure, you can eventually find yourself whereby you work your way through the system until it generates a picture of birds. Now, as you can see, it's a fairly this is a picture of birds, as it were, pose invariant. These are birds are all over the place, and that's part of the charm of this in some ways. This is a process that was developed by Alex Morgenseff, who is one of the engineers at Google, and it's referred to as Deep Dream. And it, of course, famously has produced some remarkable artworks, or I don't know if you can call them artworks, but certainly some remarkable generated images that are able to hallucinate, as it were, a series of things, depending, of course, on what they've been trained on. And you can see here, this particular one has been trained on dogs, and it looks like some kind of lamplight or something. So that was really the first step in terms of how you might begin to sort of generate artwork. And there was an exhibition of this that became the first exhibition of AI-generated art, as it were, that was staged in San Francisco a few years back. But the real breakthrough in terms of generating images came with the development of what are called generative adversarial networks by Ian Goodfellow. This happened in 2014. And this has been the area of GANs, which has really exploded in terms of the way in which architects have been using this. So what happens, this principle here is that there are basically two neural networks that are in effectively competing against each other. One network is the generator, and one network is the discriminator. You could see this as the artist or the critic in some ways, and you could also see it as in terms of, let's say, an art forger. The generator is producing something that is trying to be close to something. It's like an art forger, and the critic is deciding whether or not it's convinced about this process. And this is the technical description of what's going on. You have the generator, which is one neural network. You have the discriminator, and out of random noise, you start generating images, which then the discriminator decides whether it's real or false. Now, what happens in this process is that there is a kind of a what's called back propagation, whereby the information propagates back, and the weights are slightly adjusted to get closer to the real thing, until eventually we end up with something that is convincing enough. What is interesting about this, first of all, is that, of course, it seems to sort of echo in some ways the Turing test, which is trying to discriminate whether AI is convincingly human or not. But it also has an interesting aspect in the sense that you begin to sort of realize that there are two different modalities here. If you think about how with Deep Dream, if you move in one direction, you recognize something, and if you go in the other direction, you begin to generate something. You begin to see that maybe, and by using this as a kind of mirror to understand human operations, you can understand that maybe the artist and the critic work in different kind of ways. The artist is someone who is generating, the critic is someone evaluating, and it's as though they're two different modalities. But when you put them together, you begin to sort of realize that maybe the artist needs to be critical in its approach, and also the critic needs to be imaginative in the approach. So what happens in this thing is they train each other, and once the discriminator has trained the generator, then the generator is able to produce these convincing images. And this has a whole history. It started off initially, faces were used, partly because there were so many on the internet, and partly because faces are symmetrical and therefore easy to use. And over time, this process, this generative adversarial network, began to improve. There were different versions of this that got closer towards the more convincing. Progressive GANs began to take things further. They began to address questions about entanglement and how you might be able to move from one style to a deeper style to another. You could also generate, in this case, it's a kind of bedrooms and so on. You could use it for many things. And increasingly, as we got further on, we began to get more and more refined, until we got to the point where with style GANs, we have this really quite astonishing capacity to hallucinate images. Now, the point about this is that all these people do not exist. In fact, there is a website that's called "This Person Does Not Exist," where each time you refresh your browser, you can generate a different sort of image. So in a straightforward way, the comment made by Makoto Watanabe that machines cannot produce images that do not yet exist is clearly false. Actually, Watanabe himself holds out the possibility that, of course, that will happen in the future, and he's more open-minded about it. In terms of architecture, we can see how, and this is the work of Wan Yu He from XCool. Wan Yu He will be others with this in 3 sessions' time. You can see how you can also generate buildings that do not exist. In fact, for a while, XCool had a website called This Building Does Not Exist. And you can find many other ones. There's a website called This Cat Does Not Exist, and so on and so on. We are able to generate images of buildings. The problem here in many ways, as you can see, is it's not terribly refined. Of course, the process gets better with time. And also the other limitation is that we're dealing with a 2-dimensional image. This is not, despite appearances, this is not yet a 3-dimensional building. So we can see that already AI can be used creatively to generate things. It has the capacity to produce something in many ways quite convincing, and that is going to be improving over time. I want to sort of, having just briefly and very quickly introduced that, I want to kind of pass on to Daniel Bojon, who will be talking about cycle GANs and the work that he's been doing, which I think is truly astonishing, taking this to a different sort of level. In many ways, the problem about style GANs is that you're working in terms of interpolating existing information, and with cycle GANs, you open up into the possibility of generating a greater range. So Daniel, welcome.
Thank you, Neil, for inviting me. It's great to be here. So I'm going to show my screen. Let me know if you're able to see. Okay, are you able to see my screen?
Yes.
All right, perfect. So yes, I'm Daniel Bojon. I'm an assistant professor where I'm teaching mostly AI and computation design. And I'm also a computational design specialist with Copillon Blau, where I'm developing a deep neural law project, which I'm going to present in 2 days. So my research kind of spans quite a few areas in a way. And all these areas, I'm quite interested in the idea of intelligence. So if you're looking at upper middle part, like those are agent-based systems, so it's a sort of swarm intelligence. But we can see that in recent years, there was already an explosion of research, innovative design techniques, and experimentation addressing this kind of issue of creativity and artificial intelligence. And because of this kind of very rapid piece of advancement in field of AI, new examples of machines being able to compose songs, paint a painting, write poems or stories, they show up every single week. In architecture, although it's in early stages, we can already see some promising results when it comes to application of AI in architecture. While developments in AI mean that computer can be trained on certain creativity criteria, the degree to which AI can develop its own sense of creativity is still something to inquire about. Can AI be taught without guidance to create? Can AI be taught how to interpret things? Can AI be taught how to interpret representations from one domain to another? Like similar with what architects are doing when they are inspired from concepts outside of their domain. Teaching computers to create, it's inherently different from how people create. But we do not yet know how much about our creative methodology. So in a sense, what I'm trying, or my research, what it's exploring is the potential of teaching machines to interpret, to perceive, to be creative, propose new designs of buildings, augment design workflows, and augment architects or designers' creativity. So what I'm interested in augmentation. I'm interested in augmenting design rather than automating design. I'm interested in how can we augment design potency. So of course, when we talk about augmentation of design processes, it might be that there are certain steps or tasks that have to be automated, but that doesn't mean like the overall arching in a way idea. It's still how you augment design rather than how you just automate it. So I think this is a very old discussion going back 5,000 years at least, when we started to use oxen in agriculture. So are we designing tools then to augment our abilities, or are we designing tools as autopilots that will replace us? Any technology, as history has shown, has this kind of idea of feedback, dynamic, and momentum. And John Culkin, in a way, describes this as we become what we behold, we shape our tools, thereafter they shape us. So in this presentation, you'll hear me using, or you'll hear me talking about creativity and intelligence. And mostly what I will refer to is machine creativity or machine intelligence, which should not be understood as, or which should be actually understood as a limited form of creativity and intelligence, and not something that is equivalent to creativity or human creativity or intelligence. So after losing to Deep Blue, Kasparov, he began to experiment with different types of human-machine interactions in chess, attempting in a way to determine which types of interactions are more effective in terms of improving players' competitive advantage and how this interaction can result in augmented intelligence. He found that a mode of interaction defined by a weak human player plus a machine plus a better process is superior to a very powerful machine alone. But also more remarkably, is superior to a strong human player plus machine and an inferior process. So he described this as our goal should be intelligence amplifications, which means to use information technology as a tool to enhance human decision instead of replacing them with autonomous AI systems. So I'm going to just go briefly over the Gaudi project, where I started to deploy neural networks. So the problem here that, or the architecture problem that I'm addressing here is, this is an ongoing research that tries to look at the development of neural networks that are capable to identify relevant compositional features in samples representing Antoni Gaudi Sagrada Familia and samples from other domains like nature or other domains. So there are meaningful tectonics defined by Sagrada Familia that are constrained to a very typical naive symmetry and a sort of seriality of underlying composition. The goal here is to deploy deep learning strategies in order to liberate the intricacy, novelty, and structural properties found in the tectonic detail. The development strategies will enable this kind of intricate tectonic detail and structural property to be played out on more complex compositions. For example, a floor plan that is more free, which is something that it's kind of needed in our contemporary world. So I'm going to just go over now a few processes of how I'm engaging with this kind of networks in this project. If we are looking at the way humans perceive reality, we can say that our perceptions and our conscious visual representation of reality are not necessarily a direct mapping of the real world. We interpret reality through reconstructions and interpretations based on past experiences. Derrida, in his book, The Truth in Painting, he's talking about this concept of frame and how, in a way, our past experiences act as a filter, as a frame in the way that we interpret, understand, and perceive the real world. So in the same way, our training as architects operate as a filter, as a frame in the way we perceive the world, the way we interpret, and the way we draw inspiration from it. So in the same sense, the kind of network that we are going to work with and the kind of data sets that we are going to develop or the networks are going to be constrained to that data set, and the perception of the network is going to be more or less limited to the data set. So this is the Stalgan model that also Neil showed in his presentation. And initially, when I started these investigations mostly just try to see if machines are able to learn the representation of data. We can also think about when it comes to data, we can say that the generation of training data can be seen as a process in which humans transfer their knowledge and reasoning living inside their brain into the machine. The machine is merely an empty shell without this training data. It's a training data that transforms this empty shell into what we as humans perceive as machine intelligence. So one problem with this, as also Neil pointed out, so you have in this case a machine that was able to learn the representation of a very large data set, and it's able to create this kind of interpolations. But the problem with this is that in the end, all the new outputs that are generated are mostly just an interpolation, just a sort of average of the data set. Demis Hassabis, the founder of DeepMind, he identified 3 types of machine creativity in his lecture at Rothschild Foundation. One called interpolative or interpolation, extrapolation, and invention. So neural networks in general, they are very, very good at interpolation. We have, or they are this kind of massive statistical machines, and they are very good at averaging things out and spotting patterns in data. So in this instance, if you imagine also as a human, if you were to be given like three examples for a particular topic, very easily can in a way combine those 3 topics and then generate something that is new. So although these types of creativity are frequently attributed to deep learning, I think there are some parallels that can be drawn to also the way humans operate, not necessarily to say that they are equivalent and that human creativity is the same with machine creativity. There are some interesting similarities. As designers, we work in design spaces defined by our own artistic, aesthetical, and compositional preferences, as well as our previous experiences and training as architects and designers. As a result, our creative outcomes are constrained more or less by the design sensibilities we develop over time. So as designer, we very often engage in this kind of mode of interpolative creativity, where we construct interpolations based on previous known ideas. Of course, when we talk about machine creativity, we cannot leave out the fact that machines are not able to understand concepts, are not able to understand abstract thinking or analogies, or they're not able to imagine. So as we are simply engaging in a process of, I think a question for me here will be actually, are we simply engaging in a sort of process of preserving the knowledge or the known solutions if we engage in this kind of interpretive kind of processes? Because in the end, what we are doing, we have a data set, and that data set just gets interpolated by a network. So it's not necessarily discovering something new. Or are we looking for something that can generate solutions outside the given domain and expand our understanding? So as shown also by Neil's presentation and also the examples that he showed here with style GANs or style GANs are very good at image synthesis, but there are also other types of applications beyond this kind of image synthesis that GANs are capable of. And one example of that is image-to-image translation. So I'll introduce another type of network, which is the cycloGAN, that is able to translate from one kind of images to other kind of images without needing pairs of images. So the autoencoder is a structure that can be found mostly in all the GAN networks. And what we can do here, for example, we can say, if we have this kind of idea of paired data, where on one hand you have the satellite image, and then you have the other without green and buildings, you can say that this is a pix-to-pix model. It's a pix-to-pix scan. And what we can do here, we can simply train this autoencoder to translate the image and then compare the translated photo or image to its actual pair. So the autoencoder will use some convolution blocks, downsampling the image a few times, then upsample a few times to return the image to its initial size. The reason for the downsampling and upsampling is to compress features which might be far apart spatially, but are related in the image. The autoencoder is a key concept in image-to-image translation, and it's used in CycleGAN as well. In some cases, all we have in terms of data is two data sets that do not match. For Gaudi plus neural networks project, it will be impossible to obtain pairs of Sagrada Familia interiors and other domains images that have exactly the same layout so that we can pair them. And I think this is a problem in general, also when it comes to other types of tasks. We don't have always 1 billion images or 1 billion data points to perform certain tasks. So this is another issue and another challenge why we need networks that do not require massive data sets. So this is a very typical structure of the CycleGAN. So as you can see here, you have this kind of autoencoder where you have downsampling, and then you have on the other side the discriminator. And the way this works is the network, it's a bit more advanced than a standard GAN in the sense of it's trying to prove if the network actually learned something. So here the idea will be something like this. If I were to ask a CycleGAN network to translate from English to German, the network might be able to do that, yeah, to translate, but then was the network actually able to learn? So here you're trying to do something like you have to translate from English to German, but then you have to translate back from German to English. And then I'm going to measure the distance or the difference between the two English sentences and see how far apart they are. If they are very close, then the assumption would be that the network actually was able to learn. And the same thing happens also the other way around. So you're going to also prove that you learn from German to English and English to German. Yeah. So this is the process of a CycleGAN. So you input two data sets that are not paired, and then you ask the network in a way to try to translate from one domain to the other. So this is a very, very early example of this, where it's a kind of standard CycleGAN where this kind of translation from Sagrada Familia to forest, in this case, it's played out. And you see in a way the network trying to perform this translation. So now here for me, it's again, this idea of how can I free up the composition, how can I retrieve the relevant semantic information that you have in Sagrada Familia, and how you can translate that into a composition that is not symmetrical, is not constrained. So of course, the very first experiment, so there are some promising results. But then I started to look more into what other aspects can be, in a way, looked at and try to understand certain things. So in this case, I started to draw inspiration also from style GANs. And style GANs, they have a way of training, which is sort of progressive. They are starting with 4x4, 8x8, 16x16, and so on, yeah, pixels. And they train in that kind of way. That kind of training helps with disentanglement of features. Another aspect that I started to look at is the same way that we as humans, and especially as architects, we have a certain eye of how to look at certain architectural designs and how to extract relevant information from there. Also, networks should have, in a way, certain feature maps or filters that helps that network to identify correctly certain features that are relevant in architecture and some that are not. And then another aspect here is like, how can I reduce the data set size so that I can create the same kind of output, the same quality of output with a very limited data set. So here is just the example of the progressive training. So you have the network training at multiple resolutions and progressively, in a way, adapting or progressing in a training. And aspects then of, okay, how do we design then the machine to see correct patterns in or correct features that are relevant from an architecture perspective. And the same thing happens then to all the networks. And here you start to see then the two differences, the unimproved network versus the improved network. The network that has all these additional improvements, like the filters are improved, the feature maps, the progressive training, and also a limited data set. And you see that features, irrelevant features, start to be more and more dominant now than the other image. So like I was saying before, I'm not interested in automation of design. I'm interested in augmentation or augmenting design potency. And in this case, I'm also not interested in simply just interpolating or engaging a sort of interpretive type of creativity with this kind of networks, but I'm interested in a way, can I have networks that give something more than just what's represented in the data set. So in this instance, there is this idea of usually current approaches to neural networks these days. It's very often met where you see people using one neural network and they develop a data set, and they expect in a way that network just to be created by itself and to generate some outputs that we claim that are creative. But I think in many instances that leads to a flattening almost of design scales and design intentions very often. And I find it problematic because very often you have a lot of aspects that influence design that are not explicit in the output, in the final output. And then for me, I was like, okay, I think then a better approach would be to start to develop a sort of design process where you have specific networks that you use for specific design processes. So then it's always a sort of query about, okay, which is the design task that I'm trying to address and which is the correct network that I have to use for that specific design task in order to gain probably some insights or to augment my decision making. So in this instance, you see an example from my students from FAU, where design, it's almost like split into this kind of discrete tasks where you start to question like, okay, what kind of networks perhaps I need for this specific discrete design task, and then how that design task is connected to other design tasks. So you have then multiple networks that some of them address local scale issues, other global scale, other just pure conceptual things, other try to address aspects of how do I evaluate the results, like qualifying the results. And you see in the middle, mostly you have this kind of networks that you define certain qualifying criteria, and then you sort and you filter the results from the first phase through that kind of phase. And only after you have that kind of filtering, then you have, in a way, designs that you start to filter and evaluate and further develop. So what that translates into this kind of massive network where you have, in this case, two style gens that are mostly responsible to generate the composition in a way that is going to be translated into this kind of cycle gen. So in this instance, you have the first network is really just looking at the course styles like just a sort of positioning, overall composition. And then you have the other one that it's mostly middle styles. And then you have this kind of blending that creates then this kind of like new forest in a way that can be translated then into this kind of cycle gaps. So here you have then an entire like network where you have things connected, and this allows you then as a designer, allows you not only to engage with the network at the level of a data set, but allows you also to engage with the network at different instances of design. For example, I can have an impact, I can interact here with the network, I can interact here or in other places. So like that, I can in a way engage and have a sort of feedback between the network and designer. So these are just a few outcomes of that. So you see how far apart, in a way, these examples are from the initial interpolation studies. And one big issue when it comes to this aspects, and not only issue, but it's a question in architecture, because we are mostly dealing with geometries, 3D geometries. Most of the time it's like, okay, these networks are just operating image-based. Although I'll make an argument that also representation is very important, and a lot of design tasks, they're still going to be developed in a 2D manner. I started to address also this aspect of 3D, and right now this is the first StyleGAN 3D network that it's out there. So soon this is going to be published. So I'm just going to show a few slides of this. So this is the same like StyleGAN kind of network that at this point is mostly just interpolating. You're just able to understand the representation of the data and then create interpolations of that specific data. But this could be similar with the examples with 2D images. This could be the first step in the entire process, where this helps you mostly just to control in a certain way the composition. And then you have another type of networks that you connect to actually bring in that kind of tectonic detail that you're interested in. So this will be the last slide. This is this video that you see here. It's a video from Venice Biennale, where I started to introduce these kind of ideas of the Gaudi project. And here in this project, it's important to know that there are three key points that I'm interested in. So one is perception, one is agency, and the other one is tectonics. So I'm interested really to look at how the networks, or how to how to design the network in a way to perceive certain things in a certain way. The other one is how you interact, so this aspect of agency. And then the other aspect is tectonics. How can we learn something from this tectonics and extract that and perhaps like inform structurally design. Okay. Thank you. This is my last slide. Thank you.
Thanks, Daniel. Beautiful work. Beautiful work. I feel like I rushed too quickly through the StyleGANs discussion, but we've got a lot to deal with today, and I think this is opening up this question. I want to just, before I hand over to Lev, who will be talking about creativity itself in terms of primarily the art world, let me just kind of open up some questions about the question, or look at the issue of creativity itself. So I want to just kind of like give you some background. My view personally is that we have to really rethink the question of creativity itself. I just want to give you some sense of what we have in terms of the background. The primary kind of commentator, the person who really initiated this discussion was Margaret Bojon, and she has over the years published a series of very eminently scholarly books about the question about creativity, and most recently has been engaged with AI itself and the creativity of AI. Her book on the right hand side, I think, is one of the best books on AI, although it doesn't mention it was published before GANs became so prominent. But this has been an issue that she's been addressing over the years, kind of systematically in many ways. The problem I find with Margaret Boden's work is that she keeps, in a way, the same formula. She has a number of distinctions she makes about creativity, the different types of creativity. One of the issues she looks at is the difference between, let's say, historical creativity, she calls it H creativity, and personal creativity, called P creativity, which is problematic maybe in itself. How do we know whether anyone else has created what we've just created, and so on? And she divides it into three different categories of creativity, into three different kinds. She talks, for example, about combinatorial creativity as being one of these kind of tropes, one of these modes of things. The idea of producing kind of combinations out of familiar ideas. And the obvious example in many ways of what she's talking about here is collage, how you might reassemble components in a new way. Then another one is exploratory creativity, where you're kind of working in a way a bit like with shape grammars. And this is where really architecture fits into things in terms of her outlook. And she looked, for example, we could see the work of Emmanuel Go, who will be with us in 2 days' time on the Bauhaus here, looking at the different possible combinations that you could produce of the Bauhaus. In the center here is the Bauhaus as it has been built, but there are many other possible Bauhauses in there. So you can see how you could look at the logic of shape grammar and produce different combinations in terms of the language that's been used. And the third type she calls transformational creativity, which to her mind is really the most important kind of creativity, where you go through some kind of important phase transition. She talks about how science offers the best examples. One can imagine the kind of shift that you make from, let's say, Newtonian physics to Einsteinian physics has been a kind of a hugely transformational form of creativity, and a Nobel Prize being a kind of rewarded to those kind of creative acts that really produce these kind of game changers, as it were. And this really has been followed by a number of other commentators. Marcus de Sauty, who has a book called The Creative Code, where he looks at art and innovation in the age of AI, follows on directly from Margaret Boden. That's the kind of formula that he buys into. But my question really is whether this is the right approach towards things. I mean, one of the comments that Arthur Miller raises, and Arthur Miller's, this is another, I think, a very good book on this subject, The Artist and the Machine. He points out that really Boden is focusing on the product. Surely to be creative is to do with the creative impulse and the way that this feeds into the process itself. That there come other issues. How do we judge creativity? Someone like Van Gogh, for example, who wasn't judged as being creative in his own day, was he creative in some senses? Who is to judge? Is creativity in the eye of the beholder? It seems to me that we need to kind of, in many ways, start unpicking and challenging these rather sort of simplistic terms and interrogating them. I'm not quite sure what the answer is exactly, but I think we should start by beginning to question those things. One of the interesting kind of questions that Melanie Mitchell raises is whether, in fact, to be creative, you have to be aware of what you do. You have to. The difference between, as we were talking yesterday, the difference between artificial intelligence and AI is that the AI is not conscious. So in order to be genuinely creative, you've got to be conscious of what you're creative. And that, to some extent, makes some sense. But the only thing that I would question really is whether what we create, what we generate, is necessarily a fully conscious act. What happens, for example, when that kind of moment, the light bulb moment, where we have an idea that suddenly appears in our mind, and what happens then? Are we fully aware of these things? And the point that Max Tegmark raises, which I think I would say this is also a very, very good book on AI, is that with neuroscience is commenting that basically we're not fully aware often of the question of what we're doing in terms of consciousness. Do we know we're being creative? Afterwards, we might evaluate it in a conscious fashion, but do we necessarily know whether we're being creative or not? So all these kind of questions immediately start challenging this otherwise neat formulation that Margaret Bojon has put forward. And it seems to me that we're in a state right now where we need to start beginning to look at this in a new way. I'm going to pass over to Lev now, and I'll come back to this in a moment. But I'm delighted to have Lev here. Lev, as you almost certainly know, is the man in terms of new media art, and I'm delighted to have him. He's in Korea at the moment. Welcome, Lev. It's great to see you here.
Thank you so much for having me as a part of the series. I will immediately share the screen. So one thing I want to note before we start is that just this morning I uploaded a full set of 40 slides for this talk on SlideShare, and I will post the link to social media later today. I have 25 to 30 minutes of 40 slides, so I want to tell you about 7 myths of creativity. But if I'm able to cover 3 or 4, I'll consider myself lucky. So Neil majestically, encyclopedically organized this amazing series, and he brought people from all kind of walks of life. And I think he's correct to introduce me the way he introduced me, but I also want to add something else. Yes, I was dealing with new media art between, let's say, 90 and 2005. For the last 15 years, I was doing something else. In fact, for the last 8 years, I'm a professor in a PhD program in computer science.
So, Lev, just one question. We're having a problem with the sound. It's not coming out very well. Could you?
Just a moment. Just a second. Just a second. Sound is not coming. Okay.
It's coming, but it's not very clear.
Not very clear. Well, I am using my earphones. Should I speak more clearly? Is it better?
A little better, but maybe come closer to the computer. I'm not quite sure what the problem is.
Okay. Is this better?
Yes. Yeah, a little better. Yeah.
Okay. Okay. Well, it is strange because I'm connected to the AirPod speakers, but anyway, maybe because it has noise cancellation. Let's okay. If it doesn't work, then let me try. Let me try again. So for the last 14 years, I was directing a cultural analytics lab, where we use AI, data science, and other computer methods to study culture. And the second thing I want to say, yes, mostly my examples come from visual art, but in this slide, art stands for arts. So it refers to all cultural forms in media, including architecture, design, music, literature, and cinema, photography, dance, and performance. And finally, this talk extends some of the ideas and the work which are presented in the most recent books. One is AI Aesthetics, 2017, and the second is Cultural Analytics, 2020. So here's the 7 things I want to discuss. 1, why we're obsessed with concept of creativity. 2, modern concepts of art and artists, where do these concepts came from? 3, why do we assume that art is the biggest challenge for AI? I mean, why do we assume, I think wrongly, that art is the most creative domain of human activity? I will explain why it is so easy for AI to simulate modern art, and why it is so easy for AI to use as a kind of form generating mechanism in architecture, why this is not really so amazing. I will argue that all arts have always been algorithmic, but I will also show that AI can already create art impossible for humans. And finally, I will suggest that constantly growing use of AI in contemporary culture leads us back to an era of classic aesthetics. First of all, why we're obsessed with creativity? If you look at the manifestos and statements of artists, designers, composers, and so on, in the 20th century, the creativity doesn't appear. So the term creativity really comes into popular culture in early 2000s, so about 2002, 2003, because it's a result of globalization. So the companies start operating in a highly competitive global markets, and the companies have to innovate to be successful. And what happened in the last 20 years is that the values which we associated strictly with avant-garde modern art, creativity, innovation, experimentation, they now became key values of business in the 21st century. So I think that our obsession with discussion of AI use in art in terms of creativity is kind of reflection of this larger paradigm, and it's not necessarily an interesting question. Not the most interesting question. Now, so what about the use of AI in art, architecture, music, and design? Well, I think that if AI creates something that is very similar to existing art, architecture, music, and design, right? Using trained network, trained on large data sets, we say, well, AI is not creative, it's not interesting. But if AI will create truly original art, architecture, music, and design, we will simply not recognize it as something meaningful. We will not recognize it as art, architecture, and design. So this is a paradox of creative AI. So I will share with you just a few examples. I could have chosen billions of hours, of what I would call real human, high-level, semantic, and visual creativity. So on this slide, you see the ad created by, I think, one of the most creative companies in lifestyle era, in the lifestyle domain, the Gentle Monster, the eyewear company in Korea.
Lev, can I interrupt you again? Sorry, I think we're still not getting very clear. I'm wondering if you should go. Sorry, what if you should go to your microphone settings and make sure you've got the right.
Okay. Well, I have a. So you're not hearing me, but not very clear, right?
It's coming in and out. Is it? You've got your AirPods. Is it been changed to AirPods?
It is AirPods, yes. Is it better now? No.
It's not so great, but let's hopefully.
Okay, well, let me switch off AirPods. How about now?
Say something. We can't hear you at all.
Oh, I know. So sorry. Okay.
We can hear you now. Say something.
How about now?
Yes, much better. Thank you.
I very much apologize. I gave over 30 talks or being participating in panels in the last 15 months. This is the first time it happened. So I will just continue, right? Okay, so here's my question, right? Can AI create this level of cultural artifacts without having full equivalent of human knowledge, without having a body? Because we humans are extremely attuned, right, to details of body positions and face expressions. So what we've seen today, right, is interesting examples, but mostly it's a generation of things which don't have semantic meanings. And the question is, can AI ever generate complex semantics in the right interaction of all the references? Right? So here I'm referring to the famous argument by the philosopher Herbert Dreyfus from '72, his famous book, What Computers Can Do, where he basically already challenged the first wave of AI, saying, the knowledge is not something which is symbolic, right? The knowledge and thinking is not simply interaction of symbols. The knowledge is embodied, and it's deeply connected to having a body and being on this planet and particular biological developments. And so far, we don't know, right? So this is the works of the most famous Russian photographer on Instagram. He only uses his iPhone. And what is it about people like him, which is so special, right? I mean, why Cartier-Bresson would spend years to catch a particular moment, right? Why he can't simply put people in photograph, right? So we actually don't know, right? Why this is amazing. We don't know what details matter, and if we don't know ourselves, how can we possibly teach it to machines? Now, having said that, there is definitely progress. So things are moving in interesting directions. So this is perhaps state-of-the-art result in trying to generate art with AI, and it's a work of a Chinese student from, I think, Princeton, and she took just one class in machine learning, and she did this. So we should ask. So what we should do is we should say, not why this is so amazing, but why somebody who never used this area can take one class and after 2 months generate this. So what does it tell us about human art? And then this is, I think, even maybe more interesting result, right? So this is GPT-3. Hello? You hear me?
Yes. Go ahead. Yeah.
This is GPT-3, right? You know, and you trained, right, on large body of text, and you give it descriptions, and it does generate these kind of images. So things are moving in interesting directions. So the next question is making art, the kind of examples which I showed you, is actually relevant to AI progress? I mean, why do we think that art is the most creative human domain? Why not science, engineering, politics, vernacular design, and so on? Is it because we assume wrongly that art is the most difficult domain to formalize and quantify? And therefore, art generation is the best test for AI progress? So to answer these questions, right, we have to look a bit at the history of term art and artists. So modern concept of artist, right? Modern concept of art is only about 200 years old. It was developed in the Romantic art movement in Europe at the end of the 18th and first part of the 19th century. So the Romantic philosophers and artists developed a new concept of arts. We assume that it was a reaction to scientific progress in the beginnings of the Industrial Revolution. So instead, we invent this new idea of art, and this is, characteristics which we find in various theories and manifestos. And you can see that our complete idea of art and creativity today, it's completely was developed at the time, which means it's a historically relative idea, and our ideas, will become more important in the future. Oh, sorry. Now I lost my cursor. Okay. Sorry, more problems. Okay. Let's see. Okay. No problem. So this is the romantic idea of arts, which is also our idea. Originality, imagination, spontaneity, emotions, creation rather than imitation, rather than mimesis, the idea of genius, artist's unique vision, and expression free of rules. And why this is so sort of interesting? Because for thousands of years, humans created the best art possible without having any of these ideas, which means that these ideas are probably wrong, right? Because the art of 19th century created by Romantic artists is not any better than the art of ancient China or the art of Renaissance. Okay? And then the idea of artists is a bit older. So as you know, in ancient Greece, this idea did not exist. Painters were thought somewhere between slaves and free citizens, like very inferior people. There was no muse for painting and sculpture. Instead, we had a concept of techne, which meant mastery and skill in any area. And this leads to modern worlds such as technique and technical. Right? So an artist was somebody who was basically skilled at particular, technical area. So in Middle Ages, you also don't have concept of artists. You have a concept of craft person, and if skilled crafts were valued more than painting. And even in 1920, some kind of beautiful, vase or a table from 18th century would cost more than a Rembrandt. So this fact that we think of art, or specifically painting and sculpture, as the most valuable human domain, it's 100 years old. So finally, in the Italian Renaissance, right, one of his great theoreticians, Leon Battista Alberti, who is also architect, distinguished between technical skills and intellectual capacities, and this leads to a very tragic event, which is separation between fine and applied arts, which really starts to be taken for granted in the 17th century. So we think of art as more creative, design is less creative, which of course is, there's no data to support that. And this is, a quick screenshot. I put the word creativity in the artist in Google Books Ngram Viewer. So this is based on a database of a few million books, which Google digitized. Of course, these results are always relative, but we can see how, right, the word artist kind of starts used to be more often in books after about 1750, and the word creativity is actually much, much later after the Second World War, right? So as I already hinted, we have been asking, people who discuss these things, why synthetic art images or synthetic music or synthetic design generated by AI can fool general public but not experts. So I think instead we should ask, why is it so easy to generate art, design, architecture, music, sort of works in particular styles that look so much as the original? Right? Why they're very smart, right? Chinese undergraduate in Princeton, after 2 months, can generate these amazing images which actually look like exactly Chinese traditional painting, except different. Why is it so easy? So what does this tell us about human art and human creativity in general? Are we less original than we think? Well, so I have a whole other talk, which I'll summarize in just 2 slides, where I argue that arts have always been algorithmic, or to use contemporary language, generative. Why? Because in fact, it's very difficult for humans to do anything without repeating same templates, schemas, and patterns. So when you're writing something, right, and when you try to edit this, you notice how you repeat the same phrases or repeat the same arguments. It's very difficult for a normal human, right, to change your face expressions, to speak differently, or to walk differently. The computers can very easily identify humans with almost 100% accuracy based on their walks. Only skilled actors can do that. So I think there's a built systematicity and redundancy in all of human behavior. So when we make art or design or architecture, it's the same thing. The rules can be explicit, such as in classical aesthetics, or the rule can be implicit, but there are rules. So art has always been algorithmic, and this is why it's so easy for computers to imitate it, right? So there are numerous examples, such as Middle Eastern, ancient ornaments, and also modern art. So here's a painting by Marc Chagall. It's obvious that if you give computer part of this painting, it can kind of predict quite well the rest of it, because there's a particular, very limited way in which forms, colors, lines are treated. And this is, right, what was during Cold War promoted as the ultimate pinnacle of Western creativity, Jackson Pollock. This is even more predictable, right? I mean, definitely it wouldn't, you can probably write algorithm to generate this in two pages of processing code. So it's been particularly easy to simulate modern art. So I was thinking, why is that? I think that in modern art, but the same thing goes for lots of modern or modern avant-garde architecture, design, music, visual and semantic parameters can vary on a very large scale, right? You can have these shapes, with shapes, right? It's not like in classical aesthetics, which humans had for most of their history, where the style is, is quite limited. And most importantly, many or even all parameters can vary independently. They're not correlated to each other. So for example, I can draw a head and I can colorize it with yellow, green, orange. It doesn't matter, right? I will get nice Chagall, or I will get nice Mondrian, or I will get nice, somebody else. Whereas in the classical realistic aesthetics, right, if you use a wrong color for face or in photography, it will look weird. So as I said, in earlier art or realistic art, parameters can vary less, and also they're correlated. And finally, the tiny details, which computers are not able to get correctly now, may be most important. So here are some examples, which I did this spring. So generated following examples, selected from hundreds using StyleGAN 2 ADA, trained on 81,000 images from WikiArt from over 128 artists, and this code was created by Peter Bayliss. So here's my argument, right? If you look at both of these paintings, you can change shapes, right? You can change colors, you can move things around. There's going to be no difference in aesthetic effect, right? You can't change it completely, but you can change it a lot. And the same thing here, right? So I can take these trees, I can make them red, I can lower horizon. So the computer, in fact, is getting lots of things wrong, or we can say these results are very approximate, but it works because modern avant-garde created this approximate aesthetics, right? Where there's lots of variations and things don't have to be so precise. And this is portraits, right? Also created by the same StyleGAN. And they're amazing, but at the same time, because we're much more attentive, right, to human anatomy, when we show these images to Mechanical Turk, more people were judging these images with AI because people noticed that there is something strange happening with eyes, some strange symmetry, right? So here, in this case, the AI can't fool us. Now, having said that, let me now propose something else. But in fact, the same network or the same kinds of networks can already create art not possible for humans. Because neural network trained in lots of works of dozens of artists, such as what I showed you in a second ago, can generate plausible art images in many styles, right? And this is actually interesting, right? So the same network, the same kind of computer artist, so to speak, can generate all these different images, which postmodern artists can do, but basically before that, humans were never able to do, right? While the concept of style is so important, because archaeologists used the concept of style to date traditional cultures. Because every traditional culture had a very distinct style. So we never had culture which would paint like this and paint like this, right? So this is something quite interesting from a point of view of human culture, right? So this same network can make portraits like one on the right and one on the left. So finally, wow, amazing! I'm actually managing my last point. I'm going to argue now that the increasing use of AI in visual culture and media, in the photo apps, in the Photoshop, movie editing, all the stuff which is already built in consumer applications, which is really what we should be talking about because that's kind of more consequential than AI art. It leads us perhaps to what we can call a new classical aesthetics. Why? Because there are thousands of apps, right, for Android or iPhone, including apps from China, which have over 1 billion users. And we basically, right, used to take your photograph, take your selfie, and make it perfect. And this ideas of, making the face perfect, right, like changing face features, changing symmetry, refining beauty, and making everything perfect, we can recognize it as the typical ideas of Western classical aesthetics, whether it is ancient Greece and Rome or Renaissance, right? So the idea is that art doesn't imitate life as it is, but art, in fact, tries to get closer to the ideal. Okay? So now we can ask, are we moving perhaps towards a society with this idealized classical aesthetics where only idealized representations will exist? As we know, 19th and 20th century was a period of what I call raw realism in art, photography, and cinema, right? Stendhal, a French writer from the 19th century, had this famous statement that a novel is a mirror on a dirty road, so a novel should reflect everything. But now we're moving kind of back to art as a realization, right? So this is a typical 19th century realistic painting by Russian painter Ilya Repin. It's not particularly beautiful and really shows human suffering, and all these people are individualized. And this is, of course, classical aesthetics, right? Ancient Greece, a completely perfect human body. And it's exactly the same rhetoric we get, for example, in the advertisement for the latest AI tools, such as Luminar AI, used today by millions of photographers, right? So get perfection. So here we see image before and after, right? So before it's realism, after it's a kind of classical Greek statue. Reveal, right? We had in beauty. So it's basically never about making images worse. It's always about making them ideal. Or you can replace the sky to again create a new drama. And this very much looks like, classical European painting, something which people in the academy would paint in the 17th, 18th century. So very particular aesthetics of drama. But we can also approach this phenomena from a different point of view. That's my last point. What we see as extreme aestheticization or visual representations with effective AI can be seen as an extension of aesthetics of everyday life paradigm to media culture. And this is a quote from one of many symposiums and books in the last 15 years in philosophy, where people started to talk about the difference between Western and Asian ideal aesthetics. So Chinese, Japanese, and Korean traditional aesthetics offer a kind of living aesthetics. It's oriented towards the everyday life, right? Whereas aesthetics in the West tends to focus on the extraordinary, so art as opposed to everyday life, right? Eastern aesthetics understands art as ordinary. And I've been living in Korea for the last 15 months, and I enjoy it so much because I'm surrounded by these extraordinary aesthetics. So what in the West would be like New Pompidou Center or New MoMA, here just cafe in the middle of nowhere, right? So these examples of these extraordinary cafes, which are completely taken for granted, right? So people build these amazing buildings in Korea or Japan or China, which are just cafes. You just don't have it in the West, right? It's a different kind of approach to aesthetics, more with Korean cafes. So that's all. Thank you so much. Sorry about problems with sound.
Thanks, Lev. Thank you. Well, hopefully we'll get a good discussion going at the end about these different approaches towards things. Let me just share my screen again, because I want to just first of all, before I carry on with what I was planning to say, I just wanted to just insert in the conversation, make a few comments about in terms of the history of AI generated art, some of the issues, because these are important in so many ways. And first of all, back to say in 2018, this actually wasn't the first painting to be auctioned, but this was the one that created such a that was so controversial in many sort of ways. It was a painting called Edmond de Bellamy by a Paris art collective called Obvious, and it was auctioned at Christie's for way above what they had imagined was going to be the initial price, almost $500,000. It was very controversial because they actually had used someone else's code, and they just tweaked it slightly, and that raises a whole series of other questions about who is the author of all these things. If you're just tweaking someone's code, is it the software? Who is the author in many ways? And that's another area I don't want to go into, but this is to say, this is in the history of AI generated art, this was a famous artwork. Another famous artwork was this painting, as I call it, by Mario Klingman, that won the first ever art prize, the Lumen Prize, 2018 as well. And he asked this question really about who is in charge of the thing. Is it the artist? Is it the software, and so on? And he compares it to the piano. Is the piano the artist, and so on? So Mario Klingman is part of a whole generation of interesting new artists. This is another work that he did, Memories of a Passerby, where he takes on board. His data set is the kind of the whole history almost of the kind of Renaissance art, and you get this mutation of these portraits emerging, mutating over time. More recently, people like Sofia Crespo, and Sofia will be joining us for the theory workshop that I'm running with Marina Rodriguez Danes Neves and Victoria Barbo, and also Sanford Quinter. She is one of the most extraordinary artists. She's from Argentina and has produced some really amazing work that is really transforming the art world. Highly, highly inventive and beautiful in its own right. But I just want to mention also, the question to my mind is really, is clearly we can use AI to generate interesting artwork. But the challenge to my mind is really is whether humans are quite as creative as we think we are. We tend to think that we are more creative than artwork, but are we really? I was asked to write a what's called an afterword, a kind of response to an issue of architectural design on digital property. The concern was here is how do you guarantee copyright when things can be replicated so easy? How do we maintain that? And my response really was to say, well, hold on a second, but isn't human culture itself based on a kind of culture of copying? In the sense that the way that things propagate, there's a notion of the meme that has been developed whereby it becomes viral and it's spread just by copying, literally. Someone is humming a tune, someone else hums a tune. Someone is wearing a baseball cap, someone else wears a baseball cap, and so on. In a way, it's simply a kind of contagious operation. We end up often copying in order to go into things become popular by a process of copying. Copying from that perspective is something that is fundamental to human existence. It's exactly how culture is propagated. And Adorno raises this kind of important issue that he says that the human is indissolubly linked with imitation. The human being becomes human at all by imitating other human beings. And that, to my mind, is hugely important. And when it comes to architecture, I have to ask, are we quite as original, as provocative as we like to claim? If we were to do something totally outrageous, and the example I always give is a building that looks like a pineapple. If you were to produce, if you're a student of architecture and produce a building that looks like a pineapple, you'd probably be failed. what you're expected to do is to produce something that is close enough to the canon, and there is a canon of what is good architecture that is not exactly the same, but that is kind of following on from other works. So, for example, if you produce a design that kind of looked a little bit like Rem Koolhaas design, if you produce a design that looked a bit like Zaha Hadid or Ezozaki or Jean Nouvel or any of those famous architects, then somehow that is architecture. That is somehow, that's what we define as architecture. In other words, you have to be kind of somehow close enough to the canon. So the model that I often use to describe this is the notion of jazz. Somehow there is a background condition and you offer a slight variation on that condition, but nothing too outrageous. If it's too outrageous, it's not even called architecture. And that is, interestingly, it was what precisely the logic that this computer scientist, Ahmed El-Gamal, has used in producing what he calls creative adversarial networks. He recognizes that you have to keep close enough to the canon. At the same time, you have to sort of go slightly beyond the boundaries of what there is in the first place. In some ways, this is a kind of like a little bit like the distinction between style GANs and cycle GANs. Style GANs is a kind of interpolation within a sort of body of work, whereas because you're working with unpaired data sets in cycle GANs, you can open up and as it were, crossbreed between different works. But anyway, what he's producing is and he has a kind of let's say a factory with its AI CAN where he's producing these artworks, is kind of like variations on a theme that is simply totally AI generated. But in a sense, I think the genius of this is replicating precisely in a way what Lev was saying about how art is. You've got to kind of somehow fit within the canon or be close enough to the canon to be recognized as art. So the question then becomes in architecture is, well, if surely we get a few people who are like Frank Gehry, who just changed the name of the game on the left-hand side, the Guggenheim in Bilbao, and clearly that was a radically different aesthetic. It completely shocked the world of architecture. He produced something new, and yet you find yourself in some senses that he's kind of repeating himself in some sense. Even Frank Gehry is kind of repeating himself by producing this building on the right-hand side, the Walt Disney Concert Hall in LA, that in terms of its aesthetics are remarkably close to Bilbao. What I would say, and I think this is where I like what Lev was saying about the way that we kind of have our, shall we say, our recognizable signatures, the way people walk, the way people talk, the way people swim or sing or whatever, you can always detect who they are because you keep to the same kind of pattern. How you might necessarily explain that in terms of neuroscience. I think, for example, the way we have our neural pathways, I often think the way that you actually take certain pathways through the city, repeating in some ways the same route over and over again, kind of reflects in a way how those neural pathways work. And over time, they get consolidated in some ways. When I was teaching at the AA, I would take the train to King's Cross, and I had a certain route I would take through London to get there that was the same every time. So it's interesting in some ways how people, in a sense, get locked into some sort of patterns. You can tell a work of art by a particular architect because it always fits into that. The way that I conceive of this is really by maybe thinking about it in terms of almost like the pieces on a chessboard. A piece on a chessboard can only move in a certain sort of way. You are constrained in some senses by your kind of familiar operations. So to my mind, I would have to question whether architects are ever quite as creative, as imaginative, that they break the mold as they would claim to be. Then the question comes up is whether AI can be more creative than human beings, which is an interesting challenge in its own way. This issue was raised by Alan Turing, a kind of curious comment that he made early on. And of course, he was just simply conceptualizing the possibility of AI. But he makes this sort of comment about how creative computers could be. And he says, well, I think they could even compose sonnets. Now, this is the interesting point. And he says, though the comparison is a little bit unfair because a sonnet written by a machine will be better appreciated by another machine. What does he mean by that? Well, in a sense, if you are too creative, you're never going to be able to recognize that creativity. The example that I use, I often refer to, is this extraordinary moment. This is in the game of Go between AlphaGo and Lee Sedol. Lee Sedol one of the most famous Go players in the world, playing against AlphaGo, who they customized this particular computer to play this game. And in this game, what was really curious was there are certain moments when the commentators were all experts on Go, were just confused by the moves being made by the computer, and they thought that they were glitches. They call them slack moves. That nobody could figure out what the hell was going on because there were these moves never made before, and they thought they were computer glitches. It was only about 5 moves later that it became clear that the sheer strategic brilliance became clear. And there was one move above all others that was really astonishing, was move 37 in game 2. And this was a move where, again, it seemed that AlphaGo had made a mistake. According to one of the commentators, a smile appeared on Lee Sedol's face as he thought, oh, this is a mistake. And that smile soon drained from his face when he realized, actually, this was an absolutely brilliant move that had never been made before. And as a result of that, the whole game of Go has been changed. And as a result of that as well, I have to say, Lee Sedol gave up the game of Go. As he said, this is an entity that cannot be defeated. I simply cannot compete with this. And he made this comment. AlphaGo showed us that moves humans may have thought are creative were actually conventional. And this goes back to the question of whether if we produce something creative, if AI produces something radically creative, whether or not we would recognize it as being creative. In some ways, it's constrained by what humans think is creativity itself. So just to pick up on this kind of question that I raised yesterday, Elon Musk versus Jack Ma. Jack Ma sort of thinking that AI could never do something that's more creative, that's smarter than human beings, and Elon Musk saying, I completely disagree with that. And the point being that AI can potentially do things beyond the range of what human beings are capable of doing. So we talk about intelligence. My view, as I was saying yesterday, is that actually human intelligence only forms a certain sort of certain sector of the spectrum of intelligence as a whole, and AI could well exceed that, if we can use the term intelligence for what AI does. But the point is, if it does exceed it, we'll be able to recognize it, we'll be able to know about it. So this kind of then, in architectural terms, this has come out in the work of SpaceMaker AI, a company that's recently been bought by Autodesk. And last summer at Digital Futures, we had a panel discussion with Harvard Hoagland and Maria Dance from SpaceMaker and Wanyu He, and Daniel was also there as well. And one of the comments I thought was really fascinating was there was a particular project that they produced, and the computer came up with a solution that was absolutely counterintuitive. It was absolutely counterintuitive. It came up with something that no architect, and they had experienced architects in the room, no architect would have thought about, and yet it was a solution that really it was the best solution. And what this suggests is really that in fact, if we're thinking about genuine creativity and judging it in this kind of way, potentially AI can be way more creative. Now, this is where I want to be provocative, and hopefully we've got time now for a discussion afterwards to talk about this question about creativity. My question, and in some ways it's building upon what Lev has been saying, but in a different sort of way. When we talk about creativity, are we simply talking about a myth of creativity? Now, let me go back to this particular image and particular point, and I've highlighted the word thought. AlphaGo showed us that moves humans may have thought are creative were actually conventional. Now that's important to my mind because it's what it surmises, what it suggests is that we judge creativity. We think something is creative, and it's a question of human judgment as to whether or not we judge something to be creative. Now, was this creative? Was this move in AlphaGo creative? Well, it was a very effective move, but can we talk about it in terms of creativity? Can we even talk about whether AI can be creative? To my mind, there was a search going on, a search for the best possible move that was hugely sophisticated computationally, but it was a search. and what the computer what AlphaGo came up with was the best solution. Is that creativity, or is that simply the result of a search itself? And I think that's an important question. Are we, as it were, projecting onto AI something to do with a kind of an attribute that is human? Yesterday we were talking also about this this interview with GPT-3, and which was so convincing in many sort of ways, especially using this avatar and things. And AI was GPT-3 was producing an interview I showed with David Chalmers that was actually generated by GPT-3, but it sounded like it was done by David Chalmers. Is there not a risk of, as it were, projecting onto the computer a question of kind of human attributes? Now, I also showed yesterday this particular psychological study that was done in the 1940s. What we see on this screen are shapes. At one level, all they are triangles and shapes and circles. There is a bigger triangle, a smaller triangle that seems to be attacking the smaller triangle. And it seems like the circle is wanting to escape into this box. But what is really happening? Is it, in a way, what is really happening is simply there are a series of shapes on the screen, but we are projecting onto it. We are, through our kind of, we are projecting onto it a set of human concerns. In some ways, we are anthropomorphizing it. So to my mind, the question then is, when we're looking at a computer that is just simply going through a very rational and logical strategic search process, and we are projecting onto that the notion of creativity, are we not falling foul of precisely that same kind of question? And here I want to refer to one of my colleagues at Tongji, Costas Tzizides, who makes this point, which again is also kind of controversial. What AI establishes above all else is that every possible form is what AI establishes above all else is that every possible form is already out there, and it is simply a matter of searching for this. We had a discussion in Shanghai with Wan Yu He, and Costas had a plate of biscuits, of cookies, and he put one behind his back, and he simply said, "Okay, the cookie's actually there. We just haven't seen it before." And that, to my mind, was a kind of powerful point that all the possibilities are potentially already out there. It's simply the question that we haven't discovered it. The search hasn't been thorough enough to come across it. This is a kind of famous comment by Walter Benjamin that somehow actually also relates to, in some senses, the AI production itself. His commentary with photography, with the age of mechanical reproduction, is that the aura of the work of art withers. And maybe the issue now is not the aura of the work of art, but the question of copyright. Nonetheless, something has gone. Now, and maybe this is my own projection itself, but what do we mean by aura? Aura, to my mind, has this kind of slightly sort of religious kind of halo-like thing. It's like it has an auratic, some spirit or something like that. Does it really have that? Are we not projecting onto the artwork something that doesn't belong to the artwork? I want to just kind of comment. This is a quote that I made I made in my book Millennium Culture, and that is to say, there's no such thing as magic. We might think there's something as magic. We might take kids to a magic show where there's a magician who's pulling a rabbit out of a hat or doing whatever it is that magicians do. But that's not magic. What they're doing is what the magician is doing is simply concealing the operations that are going on, and we think that it's magic. So the question ultimately is whether we're not thinking creativity, that kind of the sort of the idea of the creative act as being this kind of genius moment is not quite straightforward in some sort of way. To my mind, what AI begins to challenge is whether there is such thing as human creativity in the first place. And let me just finish off with a kind of comment. In some ways, this was what I showed yesterday, this idea that the comment by John Searle, the difference between artificial intelligence and human intelligence is that, of course, is AI doesn't have consciousness. AI AlphaGo might be able to beat Lisa Doll at Go, but does AlphaGo know that it's playing Go? Does Deep Blue know that it's playing chess against Garry Kasparov, and so on and so on and so on? No. It has no more consciousness than your pocket calculator does. And the comment that John Searle makes with this analogy is there's someone in a room who is performing certain operations and following certain sort of kind of rules and things, and then producing something that happens to be a translation of Chinese. I mean, my WeChat also translates Chinese. Can WeChat speak Chinese? No. And so the comment on the outside is from these guys, these two Chinese guys, they're convinced that someone on the inside is able to speak Chinese, but in fact that person is not aware of that at all. He can't speak any Chinese and so on. So the question is whether this is, in some sense, you could take this again and use it to kind of to think about the question about creativity. You could imagine that a computer that is on the inside, as it were, that is simply performing these operations, is able to be creative in the same way. So I want to just stop sharing and leave it at that, and leave some time for some discussion, because I think to my mind, I think all we can do right now is call into question some of these kind of assumptions that we have in the world of AI about the question about creativity. I think to begin with that Margaret Boden needs to be challenged. I think I think that Lev's point about the art world it raises some important sort of questions, and I think that what Daniel was doing by opening up this kind of question of what cycle GANs can do was also opening up these issues about what creativity is. So I'd like to leave plenty of time for discussion here. And first of all, I would like to invite Lev to sort of to comment on the question about the myth of creativity, and and maybe Daniel too. You're muted.
Sorry. So thank you, Neil, for a fantastic overview and analysis. So one thing I want to point out, right? The way we operate in many disciplines is by ignoring what people do in parallel disciplines. So there's a huge field, right, of creativity studies. People distinguish over a dozen types of creativity, right, more than Bojon. And, if we really want to understand it, we should actually read these works. So just to kind of tell the audience that all the arguments presented by Neil, by me, by Daniel were wonderful, but there's so much more out there. People have studied this their whole life. So I think I was trying to think about what is the kind of take-home point, right, from all these 7 things I developed, and it's only came to me after my talk, right? So my key point is that what's interesting, right, is of course if you look at the thousands of years of human culture, right, humans created the most amazing, right, art, ornament, design, jewelry, architecture, music, and so on, without having concept of an artist, the art, and creativity. So it was never an explicit goal. In fact, typically their goal was to just learn from their masters, right? Learn from a workshop and just continue what you were doing. So it's not known, or perhaps, get back to the ideal of ancient Greece. So this idea that there's a progress, there's a future, that's an 19th century idea, and the creativity is actually 21st century idea. So to me, this is very paradoxical. Maybe this is the biggest, perhaps this is one of the key challenges to idea of creativity, but humans were able to get by wonderfully without having this concept. And we thought about other things, proportion, beauty, lots of very complex concepts in classical aesthetics. And today, our thinking about art aesthetics is very primitive, right? It's more primitive than at any point in human history, where we were talking about ancient China or Middle East, etc., etc. So what it suggests to me is that we should really talk about other things and forget about creativity, and then actually we'll be able to make creative AI. So by focusing so much energy on this talk, it's almost like we're beating our head against the wall, and perhaps this focus kind of blinds us to many other things which we can find in classical aesthetics, such as this idea of aesthetics of everyday life, the different ideas about empty space in Chinese and in Korean aesthetics, in millions of other things. So ultimately, if we really want to teach machines to be creative, we should look at human history. And also, I want to say, like, it was so wonderful and amazing how I think Neil and me were kind of making the same arguments, but in different ways. So I think it's a wonderful thing, you know, when you realize you're not the only person who has these crazy ideas. So thank you, Neil, for having these ideas and better ideas. So now I don't feel, you know, that I'm like this outlier.
I got, when I first presented those ideas, I got some very strange looks from various people. So it's gratifying to know that you took that same approach, Lev. So yeah.
Maybe
I think
being a bit older is like why we can have a sense of history. So we're like more skeptical. You know? Yeah. Anyway.
Yeah, maybe, I don't know, Daniel. I mean, I think that what you brought into the discussion, I think, was Demis Hassabis's kind of viewpoint, and I would say that Demis is kind of one of the most interesting characters out there because, I mean, he was actually was very successful as a chess player when he was younger. As a 14-year-old, I think he was one of the chess champions. But also, he has a background both in neuroscience and AI, and I think that he actually raises some interesting points about how we should look at the question about creativity too.
Yeah, I think everything starts from this kind of quote of I cannot create something that I don't understand or something like that. Yeah. So if you want to create networks that are actually intelligent, first you have to understand what intelligence is and how humans are intelligent, or how other organisms are intelligent, and that's how probably you can create a system that acts intelligent. Yeah. For example, Neil, you were talking about Deep Dream and AlphaGo. Not Deep Blue, not Deep Dream, sorry, Deep Blue. So Deep Blue, it's in a way, depends who you ask. If you ask a normal person that doesn't have like computer science knowledge, that person might say that that's intelligent machine, yeah? And if you were to test that Deep Blue and AlphaGo against the Turing test, it's going to pass, yeah? Because Turing test is not defining what intelligence is. It's just defining if an observer fails to see if the output is generated by a machine or by a human, yeah? That's all the Turing test does. It doesn't define what intelligence is, yeah? But if you're thinking about Deep Blue, you're saying, okay, we have a Deep Blue, and Deep Blue, it's learning to play chess. So you have about 80 million possible permutations on that board, yeah, of chess, yeah? So what you're doing, you're hard coding in a way all those moves. So then the question is, then rule-based is intelligence, or what exactly is intelligence, yeah? Or is like speed intelligence, just a machine that is able to crunch so many rules so fast? Is that what makes a machine intelligent? And suddenly you realize that actually it's not. That's not intelligence, yeah? Because Deep Blue, it's something that is very static, it's very specific, and it's very explicit in a way. It has a lookup board where you have all the, or lookup table where you have all the possible combinations. And like that determines in a way for each position where you are, determines, okay, which is the next move, yeah? So that is that intelligence. I mean, I'm not going to say that that's intelligence or not, but it's an important question to ask then, yeah? And then also when it comes to AlphaGo, it's a very big difference because Deep Blue, it's a rule-based system, yeah, or expert system, while AlphaGo, it's a learning system. So it's completely different then, because AlphaGo doesn't look at things. You don't have information hard-coded into AlphaGo. What you have almost like a sort of as a algorithm, you have to understand first the location where you are in, and then you have to understand the state of the game, and then you have to understand what's the next move, eligible move, and then you have to understand how effective is that move. And for me, it's always, I'm looking at when we criticize machines or we look at machines if they are creative or intelligent, I'm always looking at, okay, how do we define ourselves then to be intelligent and creative, yeah? So, I mean, it's for me, I think it's an important question, or important to define these things, only because we want to create something that tries to be, or we try to make them intelligent or creative. I don't know which is a perspective that Lev has here, because Lev, also you have computer science in a way background. So I'm curious in a way your take on this, because we are not talking anymore about expert systems, we are talking about learning systems. So it's important to really prove that those systems are intelligent, that they are learning, because otherwise what we are doing, we are just hard coding. And the same is the same also topic of overfitting, not to go now on a different stream, but many people are talking about AI and they are not talking about overfitting. But once you overfit, you don't really have intelligence. You just have hard-coded information. So I think these are really important questions that if we really want to understand what intelligence is, then if we really want to create systems that are intelligent, we have to understand what intelligence is.
Shall I respond?
Yeah, if you like.
Yeah. Okay. Well, you kind of switched the topic from creativity to intelligence, which is of course fine, right? You're allowed to make unexpected moves. If computer can do it, you can. But here's what I want to say. So in fact, for 45 years, since I was a student, I've been obsessed with a single idea. Can we formalize art, culture, and design? Can we understand what is the goal when I create a painting? What are the rules? And I turned to many disciplines, semiotics, psychology of art, and then computers in my mid-20s, right? So for me, what's really interesting about neural networks and supervised networks or other networks, which also will be invented beyond supervised and unsupervised, is the possibility to maybe finally answer this question a bit better than human philosophers and artists were able to do in the last 3,000 years. And here's what I think, right? So there are certain domains, right, where I think it's impossible to kind of fully formalize what is good, what's not good, what is possible. There are domains where you can be very approximate and the results still look good, such as lots of modern kind of semi-figurative, semi-abstract art. And then there are domains where the most tiny detail matters, right? So for the last 3 years, I've been watching millions of tutorials from professional photographers using Lightroom. And I think it's photographers today who are most attuned to tiny differences. So when I think that my photograph is already perfect after I spend 2 hours in Lightroom, and when I look at professional, and she or he would start making modifications, which are basically invisible to me. So if I, who spend most of my life, right, thinking and teaching art, design, art, photography, media, and so on, if I can't even see it, if only expert can see it, how can I teach it to a machine? So I think that instead of asking can machine be creative intelligence, we have to, I think, assume that it depends on the domain, right? So the machines can be creative if we can separate form and content, or maybe we can define a goal. The machines can't compete with us in the areas where tiny details or human faces matter, right? And there are other situations. So it kind of depends on a particular case. So just as we felt, history in philosophical aesthetics kind of failed, right, to define what is art, what is beautiful, how to formalize it. This idea that we can kind of use a single approach, right, to the concept of creative or intelligent, what I call cultural AI. I think it's, a wrong approach, and we have to make more distinctions.
Maybe I could just chip in. I think that to go back to this, the question about intelligence. I mean, I think that all these terms actually, I think, are really interesting in their own way. I mean, learning, intelligence, creativity. Maybe the key problem in many ways is it goes back to the Turing test in the sense, a Turing test is really whether you are taken in by, whether you judge something to be a human, and in fact, it's obviously not. So that becomes the kind of key question: is from a human perspective, you are judging things, and when we look at what AI is doing, the term intelligence, we approximate it to human intelligence, but is it actually human intelligence? When we look at learning, can we really call it learning in the sense of how humans learn? And that, to my mind, is a real kind of fragility, epistemological fragility in the whole sort of project. We use these terms, and yet are they the right terms? I think that from that point of view, that little video that I showed you, the triangles and the circles, is incredibly interesting because we read into that something that is human, but it's not there, And I think that's what humans do the whole time. We read meaning into the universe, but the universe, in some senses, is just simply kind of Brownian motion. It is this kind of thing that's doing its own thing. And I wonder whether that isn't the real challenge, that the fact that we're using terms that are really human terms, intelligence and learning and creativity that don't necessarily apply to the world of AI.
Actually, Neil, I actually want to ask you a question, right? And actually, Daniel, since you're much more experts in architecture and design, and I was just trying to like expand my slides, right? So, being an expert in art and visual media, right? For me, the crucial criteria is that the tiny details, the most nuanced relationship is what separates great art or visual media from so-so. Now, when I think about design and architecture, maybe it is Le Corbusier or Frank Gehry or Zaha Hadid, it seems to me that these buildings, we have a big scale. We don't have so many tiny details. Yes, of course, we have examples of Mies van der Rohe, designing, the door handles, but it's kind of exception. So it seems to me that architecture in general, like modernist art, allows quite a large degree of freedom, which means the computers can do very well. But if there are some examples of architectural design where tiny nuances, right, 0.01% matters of statistical difference, I think this is where AI would today fail. So I wonder if you can think about examples, because my knowledge of theater architecture is not good enough, right? Obviously, when I look at this phone, this is designed by people from 40 different professions, right? We spend months refining the texture, but I can put different texture on a phone, right? The content and the form are kind of separate. But are there some examples in architecture design where like 1% is what makes difference? Because in this case, AI, even though you can learn, it can't learn things to that level. So that's what I wonder.
Maybe I could just chip in something quickly. I think the crucial distinction that I would make in architecture is there are two modes of operating actually in architecture. One is a kind of, let's call it a strategic level, a kind of like you're trying to find a strategy for the site itself versus the kind of question of the more the design, the more close design in some ways. And we could see that distinction as being maybe between urban planning and urban design, where you're trying to think about the infrastructure and so on. And I think it seemed to me from the strategic point of view, that is where AI is really very good. And that is why, I think that, in terms of kind of that the massing model of the site and those kind of things, where you're not really dealing with the design as such, but you're just taking a background sort of strategic decisions, that's where it is really very good. And the design thing is another issue entirely. So that's what I would say, but I don't know what Daniel would come.
Yeah, I think similar. I mean, design, in special architectural design, it's a non-linear, in a way, problem. Let's say you have a lot of variables that there's no direct relation between them, input and output. Yeah, and also Anil was giving the example from SpaceMaker, and very often that's what's happening. Yeah, like if you're not able to understand the full problem and all its variable, for sure you're going to have a completely different solution. Yeah, like AI, everyone was thinking that here has to be high rise, and actually when you have an AI that looks at all the variables, you start to understand that no, high rise is not actually the best solution here. Yeah, so I think if you go in that direction, yeah, and AI used in architecture, you cannot talk about AI that is not really learning or smart or a bit intelligent or something. Yeah. Because otherwise, what exactly are you playing with? You're just playing with a tool that does something. You don't even understand what the tool is doing. Yeah, and I think probably for me that's why I'm more into. I'm really interested if the network actually is intelligent or not. Because if it's not intelligent and it's just a network that, in a way, follows a sort of rule set, it's not going to help me at all. It's just going to give me just the same kind of old solutions. Yeah. Is not going to be able to find like some strategic, in a way, advantages. So that's why then for me personally, like AI intelligence, then it's important, yeah? And not intelligence like what we define by human intelligence, yeah? But is that network actually able to really understand correctly the data set, the data that is presented to it, yeah? And is it able to generalize and to output correctly the information, Those are crucial things, because otherwise, if we play in design, we can say, well, we can brush off, in a way, these concerns, and we can say we use AI for ideation, and that's it. So it's just giving us a muse, and it's just creating very sophisticated, in a way, outcomes. And from there, we take those aesthetics and we rationalize them and we develop them into a project. Yeah. But if you think about AI actually operating at multiple levels of design and really being able to design an entire building, then it's a completely different discussion, because that machine cannot be just a machine that you don't understand what it's doing. You know, I don't know if that's making sense, if it's answering your question. That
So we do have one thing in question and answer, very interesting. You know, maybe you
Okay,
can take.
sorry, do you want to read it out?
Well, you should read it, yeah, because
I can't see it, sorry. I'm just looking
Oh,
for
you can't see it. You can't see it. Okay.
yeah, so no. So there's one from Huang Huao.
And also, there are more questions. Yeah.
Okay. Professor Neil Leach, thank you for the marvelous speech. Thank you. What do you think about keeping the same kind of design patterns like Frank Gehry is for deep exploration of the methodology, but not due to the limitation of creativity? From my perspective, the creativity of human originates from the huge amount of population, and different people create different artwork according to including architecture. So it's hard to it's difficult to compare one human with AI. Yes, I think. Do you want to comment on that, Lev?
Well, so we have a kind of Western philosophical tradition, right, which is really kind of becomes more intense, I think, in the last few centuries, which is really focusing on a single mind, right? So it's the Anglo-Saxon tradition, philosophy of mind, epistemology, aesthetics, and AI, right? So, and when people define AI in the 50s, right, like Americans, we can define it as in a very American way, right? We have to simulate a single human, right? So a single human individual. And then, of course, we have European tradition, also Asian tradition, where consciousness, intelligence, and so on are deeply social, right? Which also becomes a recently important idea in cognitive science. So that's how, like, maybe it's a bit of a different perspective, but that's how I interpret, right? So, there is a reason why architecture offices have dozens of people, and I think design is a social practice, right? There's a social cognition going on. So it's a different take on the idea of population, but I also think that our kind of people who may be in China asking questions, we're actually living in different reality, right? The human scale is so different, and I think we can learn from them, because I think we're a bit limited by our Western focus on thinking of mind, individual mind, as like self-sufficient entity. So that's because I think that's not how design works, actually.
Yeah, I mean, just one comment. We have Anna Maria Duran Callisto coming in for the architecture and philosophy session in, I think, two or three sessions' time. And she takes the view, I mean, she's from, I think, Bolivia, that actually South America was way more advanced in terms of urbanization 2,000 years ago than Europe. And, I think we all have throughout the world this kind of standard history of architecture that's very kind of Eurocentric. One could imagine alternative histories that open up questions in other ways. Absolutely.
I think just to comment here a bit about his comment of deeper exploration of the methodology when we are talking about Frank Gehry, like repeating Bilbao in Disney Hall. Yeah. I think, I don't think they are exclusive. Like, you cannot say that if you talk about interpolative or extrapolative or other kind of creativities, let's say, I don't think they are just exclusive and you say I'm operating just in one. Yeah, it might be that certain stages, yeah, they are relevant. It's relevant to use one type. The other one is a different type. Yeah, and I completely agree. And I think this is how we operate mostly. Yeah, I'm not saying it's fully like that, but it's very similar. Yeah, as humans, we interpolate. We have ideas. We have our own like culture. We have a way of thinking in that culture. If it's a Western culture or a different culture, there's a way of operating, and you're operating within that culture. Yeah, so it's a sort of interpolation of those ideas that are developed in that culture. Yeah. But if you talk about extrapolation, something more, and Neil, I think he was talking about this aspect of copying in a way. So Frank Gehry is copying Bilbao in a way. But this is, yes, of course, depends where we are talking about. Like in certain instances, yes, it's a rational decision to improve a previous strategy. Yeah, you developed a strategy in Bilbao, and probably what you do, you take that strategy and you refine it further. It's a form of interpolation, but I don't think it's something bad or good. It's just for that specific thing. I think it's a logical, in a way, task that you're doing.
Yeah. I mean, there was a comment in the chat which I take note of that would say that actually Gary didn't want to make it titanium facade. I think it was something else, a masonry facade. It's a long way up in the chat. I can't find it, but yeah. No, and I guess what is interesting in some ways, if someone does something like Rachel Wright-Reed has always been casting, her artworks are all castings. You do something, and that's what you're known for. Therefore, you have to keep producing the same in some senses. One of the things I wanted to just kind of like throw out there, we're running almost coming to the end now, but just the comment that go back to that comment that was made, Makoto Se Watanabe. Maybe I can just kind of read it out just very briefly. Yeah, machines are better than people at solving complex problems with many intertwined conditions. In that realm, people are no match for machines. And this, I think, is one of the kind of key issues in some sense, is that the complexity you're dealing with, especially when you're dealing with kind of urban questions, is more than we're able to address, we're able to handle. And when it comes to it, I think, often I was always struck by there was a review I went to at the Architectural Association where one student comes in and he says, listen, I've looked at the options and the possibilities, there are 6 of them. And you always think, well, why 6? Well, that's all we can handle, basically, And there was another student came in and said, I've looked at the possibilities. I ran them through the computer, and there are 543 of these, and frankly, 485 all look the same, but here they are. And I think in some senses, what AI can do is kind of open up that realm of possibilities beyond what we can conceptualize. And I was struck yesterday by that astonishing work that Matthias was showing, Matthias Senkati, of where I was using clip and just putting in some words, and there was a particular one who had a mosquito tent, and he had the word mosquito in a tent. You got a weird thing coming out that was a combination of those things. And it struck me in some ways, we take this sort of view that a picture speaks 1,000 words, but also a word could speak 1,000 pictures in some senses. So it seems to me that the real potential here is that possibility of AI becoming a muse that throws out possibilities beyond the range of what we can imagine ourselves, as a kind of as a tool, as an extension of human, of whatever we call it, creativity or intelligence.
Just a quick comment on this. I would like to agree with you, but as a historian of kind of digital culture and software, I just want to put a bit of a poison. Sorry about it. So this idea that a computer, an algorithm, or AI, it doesn't matter, right? Can generate lots of variations. And then the kind of human creator creates. So it's been around since 80s. And in fact, it was implemented in various video editing or design software in the 90s. And then people took it away because people didn't use it, right? So when something has been around for 40 years and it still doesn't work, maybe the new iteration of technology can make it work, or maybe there is something about these endless variations which looks very attractive, but in fact that's not how human creativity works, right? Because I think if it was really amazing, which is AutoCAD, right? Always companies would build it in, right? Because it's not hard to build in. So I'm just wondering, right? I don't think because it's so it's been around, in the early 90s. So you can wonder why it hasn't been taken up, right? So we kind of, again, I'm all for you, but when we look at reality, we see kind of different patterns,
Yeah, I see similar problem like you were saying, Lev, is we always, also in parametric design, we had the same kind of arguments, like finally we are able to explore the design space of these solutions, and we have like thousands of variations and so on, and that's going to speed up the process and so on. And no one is talking about like, okay, how long is it going to take you to explore actually the entire design space, to go through each option and to evaluate it, or to try to sort things out, And it's quite problematic because you cannot really have one system that helps you to sort things, because each one of us, we have different filters. We have different ways of perceiving, in a way, what is good, we have different ways of understanding what something for you. Something might be like genius. For me, it might not be. Maybe I don't see it. Yeah. And then it's almost like you end up like, if you have this kind of huge design spaces, then you really need personal AIs in a way that know something about you to help you navigate that. But is then the question, we are doing something to create a problem, to find another solution for that problem. So if you generate a lot of options, you thought that you solve a problem, but actually created an additional problem. And now you have to invent another solution to solve the problem that you just created. So, I mean, it's a great idea for sure. Personally, I'm looking at it from a perspective of, as a designer, you have to develop some light networks that somehow are informed by what you judge as being good or bad, yeah, in terms of design. And then maybe you have those networks that go to thousands of examples and can sort things out for you and filter them. And like that, you have a smaller pool of samples from where you can pick. Yeah, but otherwise, it's just sounds nice as an idea.
We're going to have to wrap it up because we come to the end of our 2-hour session. I think to my mind, what was interesting today about this whole discussion is how AI has allowed us to rethink what it is to be human and what is human creativity. I think that's, to my mind, the most fascinating aspect, how it becomes a mirror in which we understand what it is to be human. We're going to have tomorrow, just to say the next session will be on media art, AI media art. We have Refik Anadol coming in tomorrow, which I think is going to be a really terrific session. And then the day after that, Daniel Bojon will be coming back with Emmanuel Coe. We're talking about the architectural design itself. Lev Manovich will be joining. Hopefully we're hanging around. Hopefully you can come to all these other sessions. Lev will also be part of the theory workshop that we're running with Sanford Quinter and Marina and Victoria. So I look forward to that. And finally, tomorrow, or it's actually tonight for people in China, we have Manuel Delanda coming in for our architecture and philosophy thing, and that should be a very special moment. Manuel has had a huge impact on architects throughout the world over the years, as teaching in New York and elsewhere. So I look forward to that. So I just would like to thank our two my two guests today, Daniel Bojon and Lev Manovich. Fantastic work. I'm looking forward to the discussion about Deep Himalayan. Daniel, I think that work is fabulous, and it was great to bring Lev on board as well. Do you have a question, Lev?
No, I'm just being in Korea, I'm just expressing my so,
Oh, I see. Okay.
I'm basically communicating in a kind of Asian way, right, where people feel they're more part of society as opposed to Western individualism. So it means you project like good feelings.
Yes. And
yeah.
Finally, I want to thank all the team behind the whole Digital Futures operation. There's a whole group of volunteers working very hard to make this happen. It's unbelievable contribution to today, to this to culture and things. So thank you so much. So we'll see you the same time tomorrow. I look forward very much to seeing you again. Thank you, Lev. Thank you, Daniel. Thank you, the team behind this. Thank you.
Thank you, everyone.